Good morning. Welcome to the 11th lecture on economics, management and entrepreneurship. We will devote today to certain more exercises. Recall that on the 6th lecture, we had done certain exercises on economics, and today we shall carry out more such exercises on economics proper, including those on break-even analysis, costing, etc., on whatever we have covered till the last lecture. We will cover today, we will take up 7 exercises. The first exercise is about a Staples vegetable farm who is a potato grower. It estimates that potato output would increase by 600 kilogram with an additional 1000 gallons of water provided to its irrigation system. Alternatively, potato output could be increased by 500 kilogram with an additional 2 tons of lime fertilizer. So, as you can see from this exercise, 2 inputs are there and they are in a way substitutable, water and fertilizer. The problem is to estimate the marginal products of water and of fertilizer. Also to find out the marginal rate of technical substitution between these inputs. This particular exercise and the next exercise would require recalling our knowledge about marginal product and marginal rate of technical substitution. Therefore, I give this diagram once again, which is relevant to this particular exercise. This is showing fertilizer here in the y axis and water in the x axis. Now, for different combinations of fertilizer and water that will give the same quantity of potato is the isoquant line, whereas this is the isocost line. That is, on any point fertilizer cost and water cost would be the same as water cost and fertilizer cost here. Now, recall that we have taken df dw, this is the marginal rate of technical substitution, is as equal to del T c by del w divided by del T c by del f. So, that df comes here, dw remains in the denominator, and this is nothing but price of water dTc, total cost, against increment in water is price of water division price of fertilizer, and this is also equal to df dw, which is the slope of this line, basically isocost line. This is also the slope of isoquant line at this point. So, that is equal to dq dw divided by dq df. This dq df says the increment in q for an increment in w, which is called marginal product of water, divided by dq df, the change in q for a change in f, that is marginal product of price. So, this information we would like to once again recall, so as to be able to solve this exercise 11 and the next exercise, which is also about similar problem. Now, 2 parts of this question. Marginal product of water is straightforward, it is MP water, which is equal to dq divided by dv water. dq means change in potato, change in amount of potato grown for additional amount of water given. So, it is told in the question that 600 kilogram of potato would be additionally produced for 1000 gallon of water additionally given. So, the marginal product of water is 0.6 kilogram per gallon, straightforward. And in the similar fashion, marginal product of fertilizer is given by dq by d fertilizer, that is change in the potato production for change in the fertilizer employed. 2 tons of fertilizer gives rise to 500 kilogram of additional potato produced. So, marginal product fertilizer is 250 kilogram per ton. So, this is the first part of the question. The second part of the question is what is the marginal rate of technical substitution. That means, at what rate water can substitute fertilizer or fertilizer can substitute water. Now, this is given by d fertilizer by d water, which is same as dq by d water division dq by d fertilizer, and this is nothing but marginal product of water and this is nothing but marginal product of fertilizer. And we have already estimated the value of marginal product of water as 0.6 kilogram per gallon. So, it appears in the numerator, and for fertilizer it is 250. Remember that this is always negative. This is a case of technical substitution, that means increase of one will decrease the extent of the other input used. So, it is negative here, therefore, this is negative here, the value is minus 0.0024. So, this is d fertilizer with d water. This is, if I take the inverse, this case del of water by del of fertilizer is minus 416.6. It implies that 1 ton rise in fertilizer is associated with a reduction of 416.6 gallons of water. That means, if we apply 1 ton fertilizer more, then our requirement of water will fall by 416.6 gallons. This information we are getting from the value of marginal rate of technical substitution. So, this is exercise 11. A similar exercise is given here in exercise 12. This is regarding a pharma lab that carries out many clinical tests. Recently, it employed a new lab technician at a salary of rupees 25,000 per month. This increased the monthly capacity from 60,000 tests to 62,000 tests. That means, there is an increase of 2,000 tests because of deployment of or employment of one new lab technician, but he is paid at a salary of rupees 25,000 per month. Pharma is now considering to get the services on a monthly lease rate of rupees 50,000 of a new test equipment that can increase the current staff output by 4,000 tests per month. So, this is another way of increasing the number of tests. This was 2000 if a new lab technician is added, whereas if a new test equipment is purchased, then its output will increase by 4,000 tests per month, but the monthly expense to get the services is 50,000. In fact, it is not purchased, but leased out. So, monthly expense is rupees 50,000. The question is, does the pharma's usage reflect an optimal mix of labor technicians and capital equipment? Now, here the number of tests carried out is the output, and there are two inputs here. One is the number of people employed and the other is the capital deployed. So, this diagram we once again draw, but this time we show labor and capital as the two axes. As before, this is iso quant line and this is the iso cost line. And instead of fertilizer and water, here we are using capital and labor. So, same relationship or similar relationship. Now, this is marginal product of labor divided by marginal product of capital is equal to price of labor by price of capital. Therefore, MPL by PL is equal to 2000 rupees, 2000 number of tests, because of the price of labor is 25,000 rupees additional salary. So, this is 0.08 and MPC by PC, MPC is the marginal product of the capital deployed divided by the price of the capital. So, 4000 number of tests can be additionally performed if the new machine is leased out, and the price paid for leasing out the new machine is 50,000 rupees per month, and this ratio is also 0.08. Therefore, this condition is satisfied. Because this condition is satisfied, Pharma's policy now uses an optimal mix of labor and capital. It could operate here, it could operate here, but that the trend of the iso quant line and that of the iso cost line equal indicates that this is the optimal mix of labor and capital. Now, after this we are going to a question on break even analysis, cost volume profit analysis. This is an example from a service industry such as a hotel. A hotel has 100 rooms. It is open for 200 days in a year. The room rent is rupees 100 per day. 2 persons occupy a room. The costs of cleaning, laundry and utilities are rupees 20 per day per room. Total fixed cost of the hotel is rupees 15 lakh per year. On an average, a person spends rupees 25 per day in the shops. This should be small s. Rupees 25 per day in the shops and rupees 50 per day in the restaurant owned by the hotel. The variable cost to volume ratio is given here. This is the cost of goods sold is in the shop it is 50, in the restaurant it is 25, for supplies it is 5 and 15, and for other variable costs it is 5 and 10. The question is, at what occupancy level will the revenue break even with the cost? The second part of the question, if the occupancy level is 70%, what is the annual profit? Now, this first of all says that the hotel has 100 rooms open for 200 days, but the occupancy level can vary. The question is, what should be the percent occupancy level, that is in a particular year, should it be 30%, 50%, 70%, such that the revenue that the hotel gets breaks even with the cost of providing the services. The revenue is getting the hotel is getting out of not only room rent, but also shops and restaurants. So, various costs are given and the amount a person spends on an average in the shops and in the restaurant are also given. So, one is we are asked to find out the occupancy level at which the break even occurs and at what, and if the occupancy level is 70%, then what is the annual profit. So, first of all, we assume the average occupancy level in a year be x. The number of rooms occupied in a year therefore is 100 rooms, 200 days per year into percent occupancy. So, this is 20,000 x room day per year. Now, revenue the hotel gets out of three things. One is the rent, the other is the spending from in the shops by the occupants of the rooms, and from the restaurant. Now, room rent is given as 100 rupees per room per day, and we have 20,000 x room days per year. So, if we multiply, we get 20 lakh x rupees per year as rent from the occupants of the hotel. Now, when we compare, go to shops, per room there are 2 persons and one person per day spends 25 rupees. Therefore, per room we get 2 into 25 and there are 20,000 x number of rooms. Therefore, 20,000 x into 2 into 25. So, that would be the revenue, and that comes to 10 lakh x rupees per year revenue that the hotel gets from the spending of the occupants in the shop. And in similar fashion, we can find out about the restaurant, and that is 20 lakh rupees per year, and all this add up to 50 lakh x rupees per year. So, this is the revenue. Now, we come to find out the variable cost. The variable cost, as it says, it is a function of this 50, 5, 5, all this, they are variable cost to volume ratio. Now, we have 20,000 into x number of rooms, room day per year, and in the hotel the variable cost is, first of all, it is given is 20 rupees per day per room. The cost of cleaning, laundry and utilities are rupees 20 per day per room. So, per room, how many rooms? Room days are this. So, into 20, that is the variable cost for the hotel, that comes to 4 lakh x rupees per year. Now, when we come to shop, it is 100,000 x multiplication 0.5 plus 0.05 plus 0.05. This 0.5 plus 0.05 plus this come from here, basically 60, which is coming here as 0.6, and this comes to 6. This comes to 6 lakh x rupees per year, and in a similar fashion a restaurant comes to 200,000 x into 0.5, which is 10 lakh. The total variable cost is equal to 20 lakh x rupees per year. Now, the break even occupancy is equal to the fixed cost divided by the contribution margin, which is the unit price or revenue minus the unit variable cost. So, P minus V, and this is coming as 50%. F is given as fixed cost is given as here 15 lakh and divided by 50,000 minus 20,000, we have divided by x. So, this is the unit price and this is the unit revenue, unit variable cost. So, 50 lakh divided by 30 lakh gives 50%. So, if this means that if the occupancy level is 50%, then the total revenue equals the total cost, both fixed and variable added, which means that the hotel should try to get more occupancy, more than 50% occupancy to make profit. Now, if the occupancy level is 70%, then what we need to do is, this is the fixed cost to be subtracted, this is the revenue into 0.7 minus the unit variable cost, which is 20 lakh into 0.7. So, 50 lakh minus 20 lakh, that is P minus V, the contribution margin, into 0.7 occupancy level, that is the revenue minus the fixed cost, that will give us the gross profit of 6 lakh rupees per year. So, this is an example of how to apply break even analysis. So, the main thing here is to be able to find out the components of the variable cost in this particular example. In certain other examples, one also has to find out the components of fixed cost as well. So, the main thing is to classify the cost into two components, fixed and variable, and then find out the break even volume, where the total cost equals the total revenue. Now, we take up another example. This is an example that also talks about fixed cost and variable cost. Gopal Steel Corporation provides you with the following miscellaneous data regarding its operation in the year 2011. Break even sales value is given as rupees 66,667. Direct material used is 24,000 rupees. Gross profit is equal to 25,000 rupees. There is a mistake here. ₹25,000. Contribution margin is rupees 30,000. Sales 100,000. Variable factory overhead cost VFOH is 5,000 rupees. Direct labor is 28,000 rupees. We are required to find out the fixed factory overhead, variable selling and administrative expenses, fixed selling and administrative expenses. So, in this example, we are supposed to know how gross profit, contribution margin and break even sales are related with one another. Let us solve this problem. First of all, what are given are the following: direct material is given as 24,000, direct labor is given, variable factory overhead is given and contribution margin is given. Now, first contribution margin. What is contribution margin? Contribution margin is sales minus the total variable costs only, not the fixed cost, and total variable costs are given here as direct material is a variable cost, direct labor is a variable cost and variable factory overhead is also a variable cost. So, we add them, 24 plus 28 is 52, total variable cost. I am sorry, there is another part of the variable cost which is the selling and administrative expenses, that is not given, therefore, we cannot add this way. Instead, what we do? We find out total variable cost is equal to sales minus contribution margin. Sales are given as 100,000, sales as given as 100,000 and contribution margin is given as 30,000. So, since these two are given, we find out total variable cost as equal to sales minus contribution margin, that comes to 70,000 rupees. Now, the total variable cost is not only these three which I have written down here, but also variable sales and administrative expenses, which is not given. But now that we know variable cost as equal to 70,000, then these three being given, we can now find out variable selling and administrative expenses, which is equal to 70,000 minus these three, 24, 28 and 5. Now, that brings the value of VSAE as equal to 13,000 rupees. So, we have been able to find out the value of variable selling and administrative expenses. Now, gross profit is the contribution margin minus the fixed factory overhead. Gross profit is given as 25,000. Gross profit is given as 25,000 rupees. Therefore, CM contribution margin is also given as 30,000. Therefore, 25,000 is equal to 30,000 minus fixed factory overhead. Therefore, fixed factory overhead is equal to 5,000 rupees. So, we have found out these values in this manner. Now, we have found out the fixed factory overhead, but we are also required to find out the fixed selling and administrative expenses. For that, we need to use the information given to us on the break even sales. Now, this is the break even chart, the revenue, the fixed cost and the total cost. Now, here this is the break even point and this is the actual value at which the company is operating and it has made some profit. Now, if we consider the triangle OAB and triangle OCD, they are similar triangles. Therefore, we can now look at this. It says the break even sales is given as 66,667, whereas the actual sales is 100,000. Look at this question. I go back to the question. The question says the actual sales is 100,000, but the break even sales is rupees 66,667. So, that is what I have shown here. At the break even point, the sales are 66,667, but the actual sales, that is the operating point here, is 100,000. Therefore, I am considering these two triangles first. From here, I can say that AB divided by CD is equal to OA divided by OC. OA is, I have said x1, and OC I have called it x2, and this height is 66,000 and this height is 100,000. Therefore, this by this is equal to x1 by x2. Now, consider similar triangles PLB, PLB and PRQ, PRQ. So, this triangle and this triangle are also similar, and therefore, BL divided by QR is equal to PL divided by PR. PL is nothing but x1 and PR is nothing but x2, that is x1 by x2 is equal to BL by QR. What is BL? BL is 66,667 minus the fixed cost F divided by this height. This height is already known as 70,000 from our total variable cost is 70,000. So, this is 70,000. So, x1 by x2 is equal to this by this, x1 by x2 is also equal to this by this. Therefore, this is equal to this. If we solve, we get F as equal to 20,000. This is 20,000. This is the total fixed cost. Total fixed cost consists of fixed factory overhead expenses plus fixed selling and administrative expenses, and fixed factory overhead expense we have already estimated as equal to 5,000. Therefore, fixed selling and administrative expense is nothing but 20,000 minus 5,000, which is equal to rupees 15,000, and this is the fixed selling and administrative expense. So, you can see from this example that various costs are related and one can solve for them in this manner. Now, let us take exercise 15. Exercise 15 is regarding a small welding shop. It is considering to replace its old welding machine that it had bought 5 years ago at a price of rupees 35,000. The machine's accumulated depreciation is rupees 20,000. The machine thus has a book value of rupees 15,000, 35,000 was the purchase price, and in the last 5 years depreciation was accumulated as rupees 20,000. So, subtracting the accumulated depreciation from the purchase price, the present book value of the machine is 15,000. We shall study more on depreciation later, but for the time being we assume that the depreciation in the last 5 years is rupees 20,000. Therefore, the difference is what the book value of the welding machine is today, that is 15,000. The annual operating costs for repair and maintenance for the machine amount to rupees 4,000. Now, the machine can be disposed of now at a price of rupees 3,000. If replaced now, the machine is expected to function for 3 more years without much problem. The new machine would cost the owner rupees 10,000. It has an estimated life of 3 years and requires an annual operating cost of rupees 1,000. The question is whether to replace or not. So, this is the question. There is once again some problem here. This is small. And this I believe should be if not replaced now. If not replaced now, the machine is expected to function for 3 more years without much problem. The new machine would cost the owner rupees 10,000, has an estimated life of 3 years and requires annual operating cost of rupees 1,000. The question is whether to replace the machine or not. This is the total problem. Now, here we are facing, or the shopkeeper is facing, 2 alternatives, whether to keep the welding machine in its existing condition or to replace it by a new machine. Now, what are the irrelevant costs? The irrelevant costs are past operating expenses, the accumulated depreciation and the book value. Please recall that a cost is considered relevant if it differs among the alternatives and it has future implications. Past operating expenses have no future implications, accumulated depreciation and also book value, they do not influence the future costs and they do not differ among the alternatives. Therefore, such information is irrelevant. Now, we consider the 2 alternatives: keep the machine or replace the machine, and these are the relevant costs. If we keep the machine, the operating cost for 3 years is rupees 12,000 and if we are keeping it, there is no disposal value and we are not buying the new machine. Therefore, the total relevant cost for the 3 years is rupees 12,000. And if we replace the machine, then the operating cost of the new machine is 3,000, the cost of the new machine is 10,000 and we get 3,000 rupees by selling the old machine. Disposal value of the old machine, we get 3,000 rupees. So, this is to be subtracted from here. So, 10 plus 3, 13 minus 3. So, the total relevant cost if we replace the machine is really 10,000, whereas if we keep the machine it is 12,000. So, the decision is to replace the machine. the annual operating cost of the new machine is rupees 1000, whereas the annual operating cost of the old machine is rupees 4000. So, 4000 into 3 is 12,000, but the operating cost of the new machine is 1000 into 3, 3000, and this 3000 is the amount that the shopkeeper will get by selling off its old machine. So, the total cost would be reduced by that amount. That is why this cancels out, giving 10,000. So, the best policy here is to replace the machine. Now, this problem says that certain costs like book value, depreciation, past operating expenses, they are not relevant, and we have to consider the various alternatives, and only the relevant costs are to be considered. Now, let us take another example. In this example, we will show how service department's costs are allocated, particularly when there are reciprocating, the service departments reciprocate, meaning that they also give service to themselves apart from giving service to production departments. Now, fancy tools and dies wishes to allocate its 3 service department costs to the operating departments. These service departments and their budgeted costs, are cafeteria rupees 150,000, engineering department rupees 2,500,000, 200,000, and administrative expenses rupees 950,000. Cafeteria employees worked 30,000 labor hours per year. There are 50 engineering employees with 100,000 total labor hours, and there are 3 operating departments: machining, assembly and finishing. The number of employees deployed are 1000 for 50 and 50. Engineering hours worked 50,000, 20,000, 10,000. Total labor hours 250,000, 600,000, 100,000. So, these values are required because, as we will see, we need them as cost drivers when we allocate the service department's cost to these operating departments. Now, if you recall, there are 2 methods of allocating service department's cost. One is the direct method, where we disregard any reciprocal services given to various service departments. The other is the step down method. In the step down method, we consider the services given by one service department to another. Now, here it is asking us to use the step down method to allocate the service department costs to the operating departments, and it is said allocate costs of administrative department first, this one first, then cafeteria, and finally the engineering department. So, starting with administrative department and then cafeteria and then engineering. Now, we start allocating the cost of the administrative department. Now, the cost driver for allocating the cost of the administrative department is labor hour, how many people and for how many hours they are working. So, first of all, there are 1, 2, 3, 4, 5, 2 service departments and 3 operating departments. So, their total labor hours will be all this added: 30 for cafeteria, 100 for engineering, 250 for machining, 600 for assembly, 100 for finishing. So, this is the total labor hours and cafeteria consumes only 30 labor hours. So, in that proportion the amount of administrative department's cost, which is 950,000, will be allocated to cafeteria, and in a similar fashion only the change is here. The numerator is, instead of 30 it is 100 for engineering, 250 for machining, 600 for assembly and 100 for finishing. So, at this ratio the costs are administered there. The amount can be found out, which I have not calculated. After this allocation, the costs of various departments become its own cost, whatever it was existing, plus this amount allocated from the administrative department. For cafeteria, for cafeteria it was 150,000, for engineering it was 2,500,000. So, 150,000 plus the cost allocated, all that will be added to cafeteria. And then for engineering department it was 2,500,000 plus this amount. For machining it is this, it is for assembly it is this, and for finishing it is this. So, this is the cost of various departments. Now that we know the cost of these departments, we will then go for allocating this cost, which is for cafeteria, to other 4, to the remaining service department and to the other 3 operating departments. So, allocate the cost of cafeteria. The cost to be allocated is this, we got from here 150,000 plus all this. So, that is what we are writing here. For the cafeteria, the total cost becomes its own cost, direct cost, plus the cost allocated from the administrative department. Therefore, the total cost as far as cafeteria is concerned, after administrative costs are allocated, is this, and this is to be allocated to the other 4 remaining departments. Now, here the cost driver for allocating the cost of cafeteria is the number of employees who take their food in the cafeteria. So, number of employees, the values are given here, number of employees in machining, assembly and finishing are given here, and also are given how many workers or employees are working with engineering. So, this is 50 here. So, 50 plus 1000 plus 450 plus 50. So, that is I think is 1500. So, this amount whole multiplied by 50 by 1500 will be allocated to the engineering department, and in the similar fashion they will be added to their original cost plus the cost that was earlier allocated from administrative department to find out the cost for engineering department. Similarly, allocate the cost of engineering department later, and its cost driver is engineering hours worked. So, this is the way one would proceed. That is for exercise 16. Now, we come to an example of activity based costing. This is the last exercise that we shall take up today. If you recall, this one was not completely done in our last last lecture, but this problem was nevertheless discussed. These are the activities: material handling activity, assembly activity, soldering, testing. These are the 4 activities, and these are the variable costs: direct material for model 1, direct material for model 2, direct material for model 3, and these are the cost objects model 1, 2 and 3. There is a mistake here, it should be 80. The cost drivers here are distinct parts, insertions, parts and minutes, and these are the consumption rates. This is the variable cost and these are the consumption rates for the activities, and these are the total, this is the unit level variable costs. This we did not solve, but we had discussed this problem earlier. Now, we are giving the solution. Cost of a model is direct material plus sum of activity costs allocated to the model. Now, for model 1 this is 4000 plus, for model 1 this is 4000 plus 20 into 182,000, 182,000 multiplication 20 divided by 20, 15 and 10. How is it coming? 20, 15 and 10. So, this ratio, at this ratio this amount will be allocated to the model 1. So, 20 divided by this multiplication this will be added to model 1 as far as the material handling cost is concerned. As far as assembly is concerned, in the similar fashion it is 40 plus 30 plus 15 will be in the denominator, and in the numerator it will be 40, and that will be multiplied by 857.600. That is what we have done here. And similarly 808,400 multiplication 60 divided by 60 plus 40 plus 20, and in the similar fashion it is 592,000 multiplication 5 divided by 5 plus 3 plus 2. So, this is how model 1 is calculated, and in a similar fashion model 2 will be calculated and model 3 will be calculated. So, in this today we try to take up some exercises for different topics that we had covered in course of our lecture. In the forthcoming lectures we shall be talking a little bit on job costing and process costing, how to cost inventory, and then we shall pass on to accounting and financial statements. Thank you.